Hello, thank you for joining me. So in this video I'd like to show you how to put together your pinion gear, and this is our video number 2 in our series, a Spur gear assignment. And with that assignment we're going to be designing 3 different parts. We're going to design the pinion gear, the gear wheel, and the base that is going to be the base of our assembly that we're going to put our gears on so that we can see some motion. So I'm going to show you how to do the pinion gear. I'm not going to show you how to do the wheel gear, the gear wheel, just because it's redundant to the pinion gear. It's run off the similar geometry with different numbers. And if you remember in the previous video, and that's a test question by the way, there is a relationship between the two gears that we're designing. They are designed to mesh together. So this is the reason why we design them in pairs like this. So we have our gear set, and it's going to go together in our assembly. And and we're going to get started with the pinion gear, like right now, actually. Let's go ahead and draw a couple circles. I'm going to start on my front plane. Go ahead and rebuild there. We just had a sketch started, but we're going to start with the front plane. First thing I want to do is let's draw out our outside diameter. Now before we get started in this, by the way, and I already have my numbers drawn, but you do want to make sure that you contact or take a look at our sheet that's on the website, a PDF document. It's got kind of a step-by-step approach. I think it's 5 pages long, but in the front of that it shows you the elements that are given. So let me pull that into place. So what's given here is the gear ratio, the diametral pitch, and the amount of teeth you have in the pinion gear. From all those values you can determine everything else that's in this list. So this shows you what the formulas are on the left hand side, or in the middle. Description on the left hand side, kind of a nomenclature in regard to what that actually refers to. For gear ratios, G sub R, and so on and so forth. This tells you in this column whether it's determined or given, or whether they're going to use sketch geometry, and that's going to be something we're going to use for the base diameter. And then over here is a description of it. So the gear ratio, I think that's pretty self-explanatory. I explained that in the previous film. For every single revolution of the wheel gear, the gear wheel, there's going to be a certain amount of revolutions, typically bigger than that for the pinion gear. And mine was 2.5. So the diametral pitch, I say here it's a ratio of the number of teeth per arc inch of pitch diameter. So what you want to do is consider the pitch diameter. Remember I was talking about the pitch diameter. It's considered the circle that's between the two gears, and those circles that determine those gears is roughly halfway between the gear tooth and the void that's in the bottom of the gear, or from the top of the gear and the bottom of the gear. It's roughly in the middle there. If you think about it just being as two friction wheels touching each other, that is the pitch diameter. So what this says is the ratio of number of teeth per arc inch of pitch diameter. And with my values here, I have a diametral pitch of 32, which means I could expect 32 teeth per arc inch of pitch diameter. So it's a really small gear if you think about it. Probably more like a watch gear or a clock gear. And some of your gears are going to be bigger than that. Some are going to be probably, even a few might be even a little bit smaller than that. But yeah, so if you think about it, there's going to be 32 teeth per arc inch of pitch diameter, and that's going to be the same, and it's in a ratio that's considered the same between the gear wheel and the pinion gear. So teeth, amount of teeth in the pinion gear is n sub 1, as you can see over here. Teeth in the gear wheel is n sub 2. We don't have gear n sub 2 yet, but we can determine that, and I would suggest over here use the gear ratio for this assignment. So what you do is you take your gear ratio and multiply that by the amount of teeth that you have in your pinion gear, and that gives you the amount of teeth in your gear wheel. And what I have in my pinion gear is 24 teeth, and if I multiply that by 2.5, I end up getting 60 teeth in my gear wheel. And so on and so forth. I'm not going to go through all the equations here, but all the equations are, follow the same format. There's some qualifications down here too. You might want to read about that. When I have a d sub x, or some sort of sub x, that means you're going to substitute either a value from the pinion gear or the gear wheel to make those determinations. And one other thing I would suggest is use an Excel spreadsheet for your values. Nice thing about that is instead of using calculator, you get the same results that you would get in the calculator. But there's something here, you can borrow some of the formulas from one side and do the very same mathematical relationships on the other side for the gear wheel when you get there. And sometimes it's easier to organize. So I put everything in here in green for the values that are given. And for the gear wheel, the values are given over here too, except we need to make a determination of the teeth in the gear wheel. And then everything else is calculated as kind of reddish or pinkish over here. One thing that needs to be talked about here, we can go through each one of these elements over here too while we're at it. The outside diameter is the outside diameter of this is the very furthest extent of where the tooth of the gear is going to be. The root diameter is on the very bottom of the tooth, and it's going to be just on the outside of where the base of the gear is going to be. We're going to have a base cylinder that's going to be where all the gear teeth are going to be on top of. And we have our pitch diameters. We talked about that. So roughly in between, but not exactly, between the top and the bottom of the gear tooth. The pitch point circle, we're going to describe that as we do some sketching. Base diameter is something we're going to determine also through sketching. Angular pitch is as it's mentioned over here in our assignment. The angular circular pitch is the distance on the pitch diameter between one tooth and the same geometric reference on the next tooth. So if you go in the middle of one tooth, you go around the tooth in regard to degrees until you get to that very same point, like the middle of the same tooth on the other side. That is our angular circular pitch. It's where that repetition begins. If we go from one tooth to the next tooth, and that angle between that is the angular circular pitch. And I'll explain this a little bit more when we get to sketching, but there is a value down here called quarter angular circular pitch that we're going to use as a mirror line when we draw half of our tooth in. So when we use a quarter angular circular pitch, that'll give us, again, it gives us that mirror line. We're going to be able to take half of our gear profile one side and mirror to the other side. Now it'll become apparent as we take a look at some of the sketching. And of course the center distance between the two gears when we get our base drawn up for our assembly, when we get that modeled up, we're going to need that center distance in order to put in those posts that the gears are going to be mounted to. So I think that's enough information for this video. In the next video we'll go ahead and get started with our circles. We're going to do our root diameter, our pitch diameter, and eventually our outside diameter, and just draw some of the sketches to go with that just after that.